In the last video, you learned about Euler's line. You saw that the orthocenter, centroid, and circumcenter create Euler's line, and in this video you will learn how to find those 3 points. The first one involves the median, and the median goes from a vertex, which is where the two sides come together, to the midpoint of the opposite side, and the midpoint means that these two segments are equal length. So when we connect those 2 points, we have a median. And then the intersection of all the medians is called the centroid. So please remember to follow along, copy down all of these notes. If you need to pause or replay, that is the beauty of a video lesson. In the example, we are going to find the equation of the median that goes through point A, which means that we need the midpoint of segment BC. There's a formula to help us find the midpoint. So we do need to know all of the coordinates. So point A is 2, point B is 2, 4, and point C is 4, -2. So now, to use the formula, we are going to find the average of the x and y coordinates. So that means we need 2 plus 4 all over 2, where the 2 came from the x coordinate of point B, the 4 came from the x coordinate of point C. For the y, we have 4 plus -2 all over 2, where the 4 came from the y coordinate in point B, and the -2 came from the y coordinate in point C. When we simplify that, 4 plus 2 is 6, 6 divided by 2 is 3, 4 plus -2 is 2, 2 divided by 2 is 1. That makes the midpoint 3, 1, and we're going to call that point D. And so, to find the median, we connect those 2 points, and this is going to bring us back to chapter 5. We need the equation between -2, 2, and 3, 1. In order to write the equation of a line, we need the slope. So we will use our formula for slope, y2 minus y1 all over x2 minus x1, and that simplifies to 1/5, -1/5. Plugging that into point slope, and remember point slope is y minus y1 is equal to the slope times x minus x1, and I apologize about the handwriting, it's a little difficult on the iPad. Using the values that we have y minus, and I think I'm going to use the 0.31 when I plug in my values. So the y value there is a 1, -1/5 for the slope, and x minus 3. When we get to finding the centroid, it's easiest to have these equations in slope-intercept form. So if we solve for y, we will get -1/5 x plus 1 3/5. To find the centroid, we will continue finding the other 2 medians and figure out where those 3 points intersect. For now, we are going to go on to the next center and figure out how to find that. For the perpendicular bisector, we will be working with the line segment. We need the midpoint of this segment, and the perpendicular bisector is perpendicular to this line, which means we form a 90-degree angle with that line. The intersection of all of the perpendicular bisectors is called the circumcenter. For this example, we will be finding the perpendicular bisector of BC. We will need the midpoint of BC, but we found that in the last example, so we will just carry down the fact that 3, 1 is the midpoint. We now need a line that is perpendicular to BC. We're going to use information from chapter 5 again, knowing that perpendicular slopes have opposite reciprocal values. So if we know the slope of BC, we can figure out the perpendicular slope. If I just use the graph to count it out, 1, 2, 3, 4, 5, 6, going down 6 makes it a negative 6. To the right 2 will simplify to negative 3. That makes the perpendicular slope a positive 1/3 because we need the opposite reciprocal. Going back to my graph, I'm going to go ahead and start at 3, 1. If I use positive 1/3, that means I go up 1, right 3. I can also go down 1 and left 3, which now gives me a y-intercept value of 0, 0 at the origin, making my equation y equals 1/3 x. Drawing the line, I can see that I do form a right angle with segment BC. You will continue finding the other two perpendicular bisectors, and the intersection of that point will be the circumcenter. But for now, let's move on and look at the altitudes. The altitude is a term you have seen before when finding area. So we are going to use a vertex, and then it will be perpendicular to the opposite side. So that means we need to form a 90-degree angle with the opposite side. And the orthocenter is the intersection of all of the altitudes. In this example, you are asked to find the equation of the altitude that goes through point C. Again, point C is 4, negative 2. We need to be perpendicular to the opposite side, so we will have to go perpendicular to AB. Again, we'll need to know the slope of AB in order to find a line that's perpendicular. So AB goes up 2 over 1, 2, 3, 4. 2 over 4 simplifies to 1/2. That means the perpendicular slope will be the opposite, which will be negative, and then flip that fraction to get 2 over 1, which just simplifies to negative 2. So that makes the equation y minus, I will go ahead and use the point for negative 2, so that becomes y plus 2 is equal to negative 2 times the quantity x minus 4. And I'll go ahead and simplify. That becomes y equals negative 2x plus 6. We can also check that out by going up 2, left 1, up 2, left 1, up 2, left 1. And we find the y-intercept of negative 6. When I draw my line, I do have a right angle with segment AB, and that means the equation of the altitude through point C is y equals negative 2x plus 6. As before, we can find the other two altitudes, and the intersection is called the orthocenter. To sort through all of these terms we just learned, we've created this graphic organizer to see the similarities and differences. We have seen lines that are perpendicular, lines that pass through a midpoint, and lines that pass through a vertex. So if we put this together, the line that is perpendicular to a side and passes through a midpoint is called the perpendicular bisector. The line that passes through a midpoint and also passes through a vertex is called the median. The line that is perpendicular to a side and also passes through a vertex is called the altitude. This video showed one line for each of these special centers. In the next video, we are going to go into more detail about how to find the circumcenter using the perpendicular bisectors.